coming from Brno, Czech Republic, and I'm working in Red Hat in Brno as a software engineer for OpenShift project. So I'm not a marketing guy. I won't be selling you OpenShift, or you don't have to buy anything from Red Hat after end of this talk or something like that. I will be trying to focus mainly on the technical things, and if with God help, I will show you some live demo of OpenShift and running containers and deploying applications, building stuff, basically what you can do with Kubernetes and OpenShift together. So before I get started, just some numbers and some travel to past with OpenShift and Red Hat. So Red Hat has started with OpenShift somewhere like 6 years ago when we released first time the OpenShift Online. I don't know how many of you run application on OpenShift Online. Yeah, okay, one. So you will be really disappointed when we be migrating your application to a new version. So I'm actually happy that there was no more raised hands.
I have tried to migrate to free, it's okay.
Yeah, well, okay, yeah, but not for other, maybe not for other 2 million users that are there. So that won't be that much fun. So yeah, when we started 6 years ago, Red Hat, but basically the containers were just containers, right? So there was no fancy T-shirts with wheel logos and other things, and Legos and people getting crazy on conferencing, singing Kumbaya everywhere. So containers were basically just for nerds and hardcore software engineers who were brave enough to go fight all these Linux kernel namespaces and discover how the LXC works, how things like Linux and isolation work, how about the different file system operate with containers, how the containers can be migrated, the beautiful world of C groups in Linux kernel and so on. So that was barely like 5 or 6 years ago when we started with OpenShift v2, and yeah, it was a great success. So before we deployed online, by the way, the online deployment of OpenShift was for us, as for Red Hat or for engineers, just a playground. So because if you know Red Hat is never offering any service to you, right? So there is nothing like an Amazon AVS with OpenStack from Red Hat, or there is nothing like a Facebook from Red Hat or something like that. So the OpenShift was the first pioneer service that Red Hat offered to the customers. And yeah, it's getting pretty big, and that was actually surprising, because first when we started with OpenShift v2, we were bleeding money because all that infrastructure that was required on Amazon AVS to deploy and run this thing together, that was like thousands of dollars were flat, right? But for us, as for OpenShift engineers, this was a great feedback and great experience, because we can experience how the users that will use OpenShift Enterprise will feel with OpenShift. So we can catch the bugs and everything. Yeah. So, and as I said, we had 2 years ago when we stopped developing OpenShift v2 and we start focusing on OpenShift v3, which is Kubernetes. The OpenShift v2 has almost 2.5 million users, and yeah, the infrastructure is massive, and it's causing us a headache for migration and everything at this moment. Yeah, so the other things we experienced on that infrastructure, was like we hit the point where we received like 1 billion requests per day for all the OpenShift load balancers that were in AVS, and yeah. So that was the beautiful world of OpenShift v2. So where are we now? Is basically, let me make this larger, because these things suck. Okay. So what we are now is that 2 years or 3 years ago, a Docker emerged from nothing, right? And what they basically did was that there are containers that are useful and are sophisticated, but they are very hard to use. And for normal users, the user experience with containers were basically go write bash scripts and learn how kernel works inside to be able to create and maintain Linux containers. And then also what Docker did right was they create a uniform format for how you can distribute and how you can send the Docker image from one place to another. right? So that was something completely new, and I think that changed the industry because what we suffered in OpenShift v2 with our previous containers implementation was that you have your application running, but it's not easy to export the application from the container, right? So we can't just give you the snapshot of something, like, because the file system we use was not something that Docker is using, but it was a regular file system. So we can just star the entire content of the container and send it to you, and then when you be restoring that container back, you just hope that it will work the same way that this was working before. So this was a huge success, and since Red Hat started investing more money on Docker and have signed this partnership with Docker, which, by the way, currently is not that much partnership, but it's more like a marketing partnership. But that time, we start focusing on Docker containers, and we start thinking about how we can take our platform, which is so successful and everyone likes, and start using Docker containers so we can solve the problem about how people can share their applications, and how can people write useful containers and give it to somebody else and make his life better as well with his container. So we started a little project called GearD. I think none of you heard about GearD. So GearD was basically our way how to go from Ruby, that was what OpenShift v2 was written in, like it was an incredibly complex Ruby application, and how we go from Ruby to Go, right? And now, why Go, right? So if you look on Docker, Docker is written in Go, right? So for us, that was the lowest, that was the best interface. If you want to interfere with Docker, it's not you know, optimal to start writing interfaces and just call Docker socket or something like that. It's better to have a common place, like a common language that we can share. So we can reuse some Docker helpers, Docker function. We can also contribute to Docker if we need to and make things better. So we start writing GearD, and GearD was using systemd. So we thought, like, yeah, systemd is another thing that everyone will like and use in future. So let's use systemd for starting Docker containers. Wrong. Don't do that. I mean, like, 3 or 5 years ago when we were working on these, that was a huge failure because Docker was not built in a way that support systemd very well. There was no way how to notify the systemd from inside the container that the process is ready or working or doing something meaningful, right? So except writing some crazy hacks with sockets and named pipes and what. So that turns to be like a dead end. And then after this, Google released Kubernetes. Right, and then Google started defining what the industry of containers will look like, right? Basically, with Kubernetes. So a little bit background. I know that many of you already saw the Kubernetes talk that was, I guess, earlier today. But how the Kubernetes started in Google is that they internally run a system called Borg, which is a massive cluster deployment of literally billions of containers running all around the world in different data centers, in different zones, and so on. And they do that just for you to go read your Gmail, and reading your email is so fast. If you ever think about that, like how they make it so fast, right? Like every time I open my phone and search for something in Google, I get results immediately. Every time I open a Gmail, it is never slow unless you have millions of email there, right? Or you know, all the Google services are fast. And the way how they achieve it is that basically they internally inside Google have this philosophy of building clusters and building like a small containers and deploying them and managing them. So I really recommend you, before you start going to containers and before you start containerizing your applications, go read this article. I know that you can't read it at this moment, but I think I will share it on Twitter or something after presentation. So if you go read it, this article is from Brandon Barnes and Michael Oppenheimer, which are like chief architects from Google who are behind this Borg system and who were behind the Kubernetes itself. They basically defined different patterns that they observe inside Google, but also outside Google, that people use with containers. Right? So the most simple one is the single node, single container. Right? So a container itself as a unit expose three simple functions: run, pause, and stop. Right, and that's it. So whatever you run inside that container is isolated from the rest of the system, and you have these three methods to manage the container itself. Very simple, right? So which also said don't run things like the systemd inside container. And I will get to that later, why it's not a good idea. So then another pattern is multi-container, right? So if you have one single container and you run something there, it's not very useful for you as well, and also for orchestration and management point of view. Like imagine that you have a huge Java application and now you just put it inside container and run it there. There's no value of doing that, right? Especially just to get it into container. That's like, it's not useful at all. So if you look at the multi-container, that gives you more options, right? So if you think of container as a unit where you can, when you can collocate like two containers together and make them useful together. So you have a main container, which is your application, and then you have a sidecar container, right? So imagine that your container with your application run Nginx or Apache or whatever, and is a logging, right? And the sidecar container basically scrub the logs and do something with them, right? So when you start these two, you always start these two together, right? To work together because they're closely working together about serving your application. Then you have the ambassador pattern, right? Where you have, for example, that proxy for memcache, like so tweet mem or something like that. So it basically, you add a second sidecar container that will pretend it is a memcache. And your application will use that sidecar container. It will connect through localhost or something like that. And that sidecar container knows how to talk to this memcache cluster thing. I can't remember. I can't recall the name. I probably have it written down here somewhere. TWEM proxy, right? So this thing know how it can call to TWEM proxy. So it basically abstract is a service for the main container with your application. Then you have an adapter pattern, right? Where you have some monitoring agent, for example, and your container is talking to that monitoring agent, and that adapter is giving you a connection to your monitoring system or something like that. So it's making it easier for your application to talk to that monitoring system. Besides these single node patterns, you also have a multi-node patterns for containers where you don't run just one Docker host, but you can run like thousands of hosts with Docker in it. And then each host can run multiple containers. And there are different patterns. Leader election. Imagine that you have a sidecar container, and that sidecar container knows how to do leader election, right? So you can deploy like five pods. Right? Let's talk about it as a pod. So pod is one or n containers. So you deploy 5 pods. Each pod has a one main container with your application code, and then a sidecar that knows how to do leader election. Right? So and then for your application basically gets the leader election system for free just by using that sidecar container. Right? Then you have this scatter-getter system. This is probably most used in Google, where this is how your search works in Google, right? So what is happening is that you have a piece of information, which is your search query, and you just drop it to containers, and then it will give that information to like thousands of containers, and every container will do some chunk, right? So it will try to get something, and then they will collect the results and give you the search results in the end. That's a massive parallel. Like, imagine like if you do a Google search, your query is probably running inside like 1,000 containers or something like that inside Google. So now how we get to Kubernetes. So we know there are containers, there are different patterns that you can use with containers. And let's talk about Kubernetes. So inside Kubernetes, I think you already heard this today, but I will repeat it really fast. The basic unit you can deploy inside Kubernetes is pod. So pod can be one or n containers, but also the volumes that are connected to those containers. And the containers are always scheduled together with the volumes. And they are scheduled on one node, right, which is important. So imagine you're writing your application, which is foo app, right? That's a name of the Docker image, right? And then you create it on Kubernetes. The problem with Kubernetes here is, and I will get to that later, is that in Kubernetes the images are not the first-class citizen. So Kubernetes, basically, the Kubernetes guys are telling us that the images are coming from user or from CI/CD system. And Kubernetes itself, as a platform, is not responsible for managing images. That's a problem for image registry or Docker registry or Docker Hub or whatever, or user, right? So they don't really care about user images or Docker images or container images in general. So you have a pod, and then when you have a pod, you say, okay, I have a pod, I want to run it like 3 times, I want to scale it, right? So because now I have this fancy Kubernetes cluster system with hundreds of nodes running, I want this thing to be like rolling. I want to have 1,000 of replicas of my application so it can be super fast. And the way how you achieve it in Kubernetes is that you basically define a replica set, which is YAML file or something like that, and you put that pod template, so the definition of that pod to that replica set, and you say how many replicas you want from Kubernetes to be running at any time, right? So if you create that replica set, Kubernetes will observe that creation and will say, okay, I don't have 3 replicas of this pod, let's try to create it. And Kubernetes will then go and to the nodes and ask them like, create this pod, create this pod, create this pod. So until that pod will be created, it will be trying forever, right? Which is very important to understand if you are working with Kubernetes. In Kubernetes is very declarative. So if you say, I want 3 replicas, Kubernetes will do whatever it takes to create 3 replicas for you, and it will try it forever. There is no failure mode here, right? So if it fails to create one of them, it will try on a different node. If it fails on that node, it will try a different node, and it will try forever, right? So, and now, okay, so yeah, I have my 3 pods, I have replicas, not really useful yet, because what if my developers will send me a new Docker image with my application, right? So what happened then? So, okay, I can just edit the pod template, right? And then what? You think that Kubernetes will automatically recreate those pods? No, just keep running, right? Like, you have 3 replicas. I don't know that. So what you have to do in that case is to go and manually scale it down to 0 and scale it back to 3 so it can get new images and new updated pods out, right? Which is not really practical. So what they add in a recent version, I think it was added 1.3 or 1.2, is the resource called deployment, where you can define a pod template and replicas, and that deployment will create a replica set for you, right? And every time there is a change inside that deployment, in a spec of that deployment, so you change the pod template. So, for example, add a new image, right? Or add a new environment variable. If that change is observed, Kubernetes will go create a second replica set and will start scaling down the pods in the first replica set and scale up the pods in the new replica set. Right? So that strategy is called rolling strategy. There is also a recreate strategy where if you have that strategy, that basically means that the replica set 0 will be scaled to 0, and replica set 1, the new one, will be scaled to 3. Right? But the rolling strategy allows you to have a 0 downtime because the pods are replaced like 1 by 1. So that's very practical, and that's all the deployments are currently doing in OpenShift, in Kubernetes, and they are in beta right now, right? So maybe we will need some more, but let's see. So OpenShift, how we get to Kubernetes in OpenShift. So first off, we discovered that Kubernetes is built in a way that allows extensions. So you can just extend Kubernetes. And the way how you do that is if you are familiar with Go, right? It's very easy to just vendor something and then just add your code and say like, this is a new thing, right? This is pretty common practice in Go world, basically. And this is how dependencies are managed in Go. You just vendor the entire project as it is, and you import the paths or import the structs and functions and packages you want and use them, right? So you can import the entire Kubernetes, right, as it is, and just add your custom functions. So you can also register your new API types. So I was talking about pods, replica sets, deployments. You can add more. You can add your own Kubernetes types if you want. You can also reuse the internal clients, right? So Kubernetes have a lot of clients for everything, for caches, for like helpers for the clients, the things how the pods are scaled, the kubectl itself, So and with kubectl you can also register your new commands to the CLI. So you can just add literally new subcommands inside kubectl the way you like. So, and now, this is really important announcement because I'm going to correct what our marketing has done and how they damage OpenShift, because they were saying that OpenShift is just yet another platform as a service or something. So no, OpenShift is currently a distribution of Kubernetes. So what that means is that OpenShift is on the same level as, for example, CentOS and RHEL are distribution of Linux. So Kubernetes is just a way, or just an orchestration tool or a management tool that runs containers. And OpenShift is just a repackaging of that tool with some add-ons or with some additional functionality to make a developer life better, right? And with other functions that I will get during the demo or in the end of the presentation. So, and for that, it's really important to understand that Kubernetes 1.3 is basically OpenShift Origin 1.3. We even matching it with the versions at this point, right? And we will try to keep the matched two versions. Kubernetes 1.4 will be OpenShift 1.4, right? And the OSC is the enterprise version following. So OpenShift is really Kubernetes, nothing else. So it's actually much easier, as Kelsey said last time, it's easier to use OpenShift when you want to start working on Kubernetes or working with Kubernetes or just playing around with Kubernetes, because we provide that bootstrapping tools that gives you the full Kubernetes in like 30 seconds. And you don't have to install everything on your laptop, and you don't have to compile stuff, and you don't have to run like a complex Ansible scripts or something like that to give you Kubernetes on your Mac or something like that. So what it takes to build the PaaS, right? Let's talk about what is missing in Kubernetes and what in OpenShift we think the platform should have for developers to make it more useful, right? So first off, Kubernetes developers still care more about writing source code than writing Docker files, right? The developers write source code. Don't make developers write yum install or something like that and configure some crazy config files inside Docker files, because developers don't know how to do that. Right? That's why we have administrators and DevOps and other people who understand the complexity of the base image and the software installed there, the dependency hell, the security issues. That's not, developers don't care about that. Developers just want to have the latest and shiniest libraries and everything. But if you take that away from them, you will realize your entire world will be more beautiful by that, because then you will have DevOps have solved the problem of base images and shipping, the applications themselves. Developers also want to iterate fast, right? So they want to have a fast deployments. Every time they make a change, they want to have the Docker images for the application rebuilt and just deployed like instantly in 5 minutes, right? So they can go to managers, and managers can see like, yeah, this is the change we requested, perfect, it's there, right? So, and the problem with that is that deployments of applications nowadays are really complex. It's not just a simple PHP web page or something like that. Usually there are like hundreds of services connected together. So if you redeploy one image, you might break the entire system. And so we need to make this easy for the developers to deploy and test their changes and deploy to from development to production. And yeah, we are all agile now, right? So the managers and stakeholders wants to see the results like every 3 weeks or something like that. So that's also why. And yeah, the developers also need some fancy tools, right? So with a lot of colors and beautiful pictures and visualization tooling and UI, and so they can see how the application is working, if it is working. If there are problems, they can they want to be able to debug that application and do a canary deployment just to see if the changes they made make sense or they break system or not, right? So that kind of problems the developers are having with containers. And then from the administrator's point of view, that's a different world, right? Don't try to, like, DevOps, I hate that word. So let's talk about administrators. So administrators are also sensitive to tools, right? So because administrators usually just have, maybe they know Python, they all know Bash, and they have a lot of, they probably know all the parameters for sed and other tools just from out of their head. So they're very sensitive and tooling and how they interact with the entire platform. They also want to have tools that just say, I have these nodes, and I'm going to take this node out because it is damaged. It has a damaged hard drive, or it has some problem with the software, or it has something broken in it. So I need to reboot it. So for them, they need to have a tool that just take that node down, evacuate everything that is running on that pod somewhere else, right? It's just a simple tool. They also need to be able to configure the authorization and authentication for the entire cluster. So they can see who is going in and who is going out and who is doing what and how the users are doing that. So they might have configure roles, permissions, and limit what the users can do with the cluster so they don't do any damage. And they also need logging and monitoring. So if something goes wrong, they want to be notified. They want to get a message from Prometheus or something like that if something wrong happened. So the other thing that they care about is installation process, right? As a sysadministrator, you're probably familiar with Puppet and Ansible and all these kind of tooling, or you just hardcore and go install yourself with yum install and configure everything every time again and again. Right, so OpenShift has the Ansible installer. So if you just go to that GitHub URL, you will get Ansible installer for OpenShift v3. If you run it, you can run it against Amazon, you can run it against OpenStack, you can run it against like a bare virtual machines. I run it against DigitalOcean, and I just got OpenShift in 5 minutes. It was just pulling the images was taking like 3 minutes. So it's really fast to install OpenShift itself and configure it. Also adding in nodes, removing nodes, configuring new nodes, upgrading, that's also all part of this installer. If you do it with the AVS, it has even a plugin, so you just give the installer your Amazon key and Amazon secrets, whatever, and it will also create the instances for you and everything. So you don't even have to provision machines or something. And yeah, for developers and admins, there is Vagrant always just for playing, and the OC cluster app, which we've rolled especially just to give people a way how to boot the entire OpenShift in Kubernetes in like 30 seconds, right? Because somebody in our engineering is crazy about 30 seconds. So how it looks like, it's this. Let me try to fix this. Yeah, never put, yeah. So if you run OC cluster app, it will just check if you have a Docker. It will pull the OpenShift origin image. It will check a couple other things like server IP and other unimportant stuff, and it will run OpenShift. Then you can create your project, right, where you create your application, you list what applications you can create, and CakePHP is one of the examples. So you add CakePHP to your project, you see that, yeah, it's building, so it's downloading the sources and building the Docker image. Yeah, status is that, yeah, you have everything created, and you just curl and it's done, right? 30 seconds. From basically a host with just Docker to a full Kubernetes machine that you can just go create the pods and use a kubectl and just play around if you want. So when we're talking about building applications, what developers do, right? So what should developers do, and what should the platform do for developers? So developers basically just do code, right? So you just do some code and test it locally. Everything works. Push it to GitHub, right? Done. Call it a day. So and what platforms should do for developers is that every time you make a change in your source code and push it to GitHub, the platform itself should observe that change. Like, yeah, there is a change inside this Git repository, and this repository has a configured build, right? So if there is that configuration for this repository, just go schedule new build for this application, right? And create the application container, new updated application container image. Then, if that image is built, the platform should go push that image to an image registry. Right? And now we are getting to, does Kubernetes offer image registry? No, just because Kubernetes is not a platform as a service or something. It's not meant to be used just for developers, but also for running containers. So at OpenShift, you have this integrated image registry. So then the container image is pushed to that image registry. And what should happen next is that the system, the platform should observe that, yeah, well, there is a change inside that image registry for this image. There is a new image available with new SHA or something. And if that happens, it should trigger a new deployment for the application. So basically, every time you make a change inside your application and push it to GitHub to a master, your application is automatically updated and redeployed, right, by the platform. Of course, this is a very simplistic view of world, right? In practice, this never worked like this. There are more things in between and all around, but in theory, like, this is the wet dream for every company to have, like, and managers. How this works technically is basically, yeah, as I said, you have a GitHub app, you have a build configured. Let's say it's a Go application. So you say, like, yeah, from Go 1.5 Docker image, I want to build this source code that existed on GitHub, and I want to push it to app v1 in the Docker registry. When this happens, it is pushed. In OpenShift, we have this concept of image stream. So image stream is a resource, a virtual resource that lives inside OpenShift, and that basically is a system that tracks the images inside the Docker registry or image registry itself. So every time a new tag is created in Docker registry, that image stream is updated, right? So we can then just watch the image stream inside OpenShift and Kubernetes, and we can trigger things like deployments or do some action where the image change, right? That's what image stream is for. And now, so as I said, this is a very simplistic view of application development, right? So from my computer to a production. But in real world, that is much more complex, right? So usually that application have, or in a microservices world, let's say, that's not just one simple application, like it's not just a Rails app and done, right? Those are usually like thousands of services. Like OpenStack has 100 services running inside containers. And now imagine that when you want to update just one of those services, right? So to make sure that the entire system works well after that update, that's a lot of work, right? And that's a lot of scripting, a lot of checking. You also need to think about things like pipelines, right? So every time you make a change, and there are like 100 services, you might have execute a pipeline that will build a new container, create a new project, like a virtual testing project, deploy the entire application there, like make sure that the health is okay for that application, nothing break, and then report back to the pipeline that, yeah, this step is okay. Let's deploy to stage, right? So the application is deployed to stage, then your quality assurance team will jump on it and will try to break it. And if they are satisfied, they can approve the next step, which is deploy to whatever, production or pre-production and so on. So that you also need to have pipelines, right? And as I said, for deployments, as the example I was showing with Kubernetes deployments are very simple. So they miss some features that we think developers or DevOps might need. For example, lifecycle hooks, right? So imagine that there is a new Docker image available and the deployment is rolling an update, right? Where in that process you execute your migration to a database? If that's a Rails application. So let's say you add a couple new models inside Rails and you modify the DB schema, where you migrate, right? So the application is deployed, that's fine, but the database is old and application is talking to an old database, right? So you need to have a lifecycle hook. So basically, when the deployment is going inside, in the middle of that deployment, you stop, right? And then you execute the script that will migrate the database, make sure everything is okay, and continue, right? Of course, database migration is like more complicated topic, like how you, for example, roll back in case there is a failure or something. But yeah, it's something that we need to make better in Kubernetes. Triggers as well. Like in Kubernetes, the way how you trigger a deployment is you just change the template spec. That's it. That's the only way how you can trigger a new deployment. Right? Every time you do that, Kubernetes will calculate the hash for the spec inside the pod and use that as a name for a replica. And that's it. If that hash is already there, nothing is deploying. And there is no way how you can force Kubernetes to deploy something. But that's again, Kubernetes doesn't know. Like, for example, imagine that you have an image and you're using something like a app and tag latest. How Kubernetes know that your latest is now even more latest because you push a new tag in it, right? So it's latest, nothing changed. Inside the spec is all the same. So you need to have the way how you trigger a new deployment and make Kubernetes pick up a new images if you want. And yeah, sometimes rolling and recreate strategies for deployment are just not enough, right? So yeah, the recreate is basically put down old deployment, create a new one. That's simple. Rolling is more complicated, where you just replace pod by pod, right? But maybe you need something more complicated. Yeah, you just replace pod by pod and then stop in the middle and check if some service is running, and if it is, like back up my database, and then return back to deployment and continue to some level, and then break again, and make sure that, you know, it's the deployment process, it's very complicated. And yeah, I think that's it. That's stop talking, and I will start showing some demo. So how it looks like. But for that, again. If you have any questions so far, like just ask, because this might not end up well. Okay. Okay, can you see this? Okay. So what I'm showing you here, this is the OpenShift Web Console, right? So if you, this is the thing that you get when you do OC cluster app. That's 30 seconds thing. So if you go inside in your browser to the IP address that OC cluster app give you, and you log in as a test admin or whatever admin, because authentication is disabled for developers, you can log in with whatever, you will get something like this. Like, these are your projects, right? Well, you won't be able to see these because you don't have a permissions, but I just modify the permissions so I can see it. The default namespace inside Kubernetes is special because that's where the infrastructure containers are running. So by infrastructure, I'm meaning things like Docker registry and router, and the Kubernetes itself is there. I mean, Kubernetes as a service. But I created my dev sample project. And what I have inside this project is a little CakePHP application, which has 4 pods running. That means 4 containers, and it also have a database linked to it because it's using database. So if I go to this deployment for CakePHP, you can see some details about this deployment here. So basically, I said I want 4 replicas for this application. My strategy is rolling, so every time I deploy, it will be 0 downtime, basically. And yeah, there are some deployment related methods, and there is a template for the container of the application itself. So it's using image test CakePHP, and this is the tag it uses. That image was built by this build configuration. I will get to that later. And yeah, by source, like when we build this application and we clone that application from GitHub, this was the last commit there. And yeah, it exposed port 8080 on TCP because it's a web application. And it has a readiness probe, which means this has to pass in order for Kubernetes to register it as an endpoint for a service, so to be alive. It doesn't have any volumes, but I can attach some storage. It doesn't scale automatically, but OpenShift can scale the application automatically for you. So I can add the autoscaler. Oops, I can't because I don't run metrics, which require JBoss and another 16 gig of memory in my laptop. So I won't be showing you that. But if I have metrics, that means that I can configure what is the minimum of pods I want to keep running for this application and maximum of pods running for this application. And then based on the metrics reading, when your application will be taking a lot of load, like a lot of requests, or it will be busy, OpenShift will automatically scale it up, right? Based on that values. So that's the autoscaler, basically based on metrics. You go back here. This deployment have a trigger, so I can just trigger it manually by command line, just by executing this command, or I can just go press this button. Or every time there is a new image available inside test CakePHP latest. So every time there is a new image there, it will kick a new deployment. Now, you maybe notice there is a latest. How we know there is a new image? That's just because when we build this application and it is pushed to an image registry, that push will create a manifest, and we import that manifest inside OpenShift, and we'll read the SHA of that image and store the SHA. So that means we can still point on latest, but if latest change, so it has a different SHA, we treat it as a new image, right? So we can trigger based on that. And yeah, every time you change this configuration, every time I add an environment variable here, or every time I change a replicas or something, this deployment will automatically trigger. So that's deployment. And now let's go to build.
Can I?
Yeah.
Can I see somewhere how is it connected to database? Settings somewhere?
You mean this application? How?
I'm trying to see two pods. One is the app together with database. Can I see where are they?
These two?
Oh, yes.
Yeah. So if I go here. Yeah, how they are connected.
Yeah.
So this application can use the database has a service. So the service is called MariaDB, right? So if I have this service running, that's an actual object inside Kubernetes service. It has an IP address. So the application then you can use the host name MariaDB in this case. I can call it database or whatever. It can use it as a host name, and it can just connect to that database using that host name. And since this container have also environment variables somewhere. Okay, so this is the service, right? So it's running on port 3306. But what I wanted to show is different. So this container has some environment variables, right? So it has a user, password, and database set. And if you have these inside one project, and in OpenShift, when you link it together, then inside this container, you also will see that environment variables. So you have a host name, you have a username and password, and you have a port as well for the service. You can just use database. The credentials are coming, so yeah, I will show you. So the way how I can add the database to the project is this. So I go add to project. There's a couple of templates here. But when I choose MariaDB ephemeral, it allows me to set some parameters, right? So a memory limit, name of the database service. I can call it a database this time. Now I can set username, password, and the database name, the initial database name. So when this container will get up, it will pre-create that database. And if I leave this empty, it is generated by a random string. So you can specify a random parameter name, and that is generated. That's an OpenShift template, basically. So if I now create these, Oops. Yeah, so it will try to deploy it and run it forever. Yeah. Yeah, so now it is running. Right. And I have no group service here, so I can just group some service like.
Once you group them, they can see each other.
Exactly. Well, they can see each other if they are inside the same project. I don't think they share environment variables and secrets and other stuff. That's why you're grouping them together. Yeah, yeah. So builds is something that doesn't exist in Kubernetes, right? So because Kubernetes doesn't deal with the Docker or image registry itself, or Docker images or images as well. So they don't have the need to build them, right? Or give the user the ability to build them. But in OpenShift, when you're building something useful for developers, and developers care about source code, they don't care about the building of Docker image for themselves. So they can just create this I can just create this configuration for my application. I'll be showing, right? And I can specify what will be the build strategy. That's a source. In OpenShift, we have this source to image project that basically have a set of Docker images that acts as a builders, and then you can just add the source code to that builders and execute a couple of shell scripts that will build your application and commit that image as an application image. So as a developer, you don't even need to write a Docker file or something like that. We know how to build your application just by having that language image available. But I won't be talking because that's another 1-hour presentation, how this thing works. So I have my builder image, which is a PHP 5.6 version. My source repository is this. That's a regular GitHub repo. Source ref is master, so every time there is a change inside the master, we should clone the master and build it. And this is outputting to test CakePHP latest Docker image. And the run policy is serial. This was recently added, so you can have a parallel and serial, right? So if you have a serial, that means if there are commits coming to your application, if you don't have the serial or use parallel, every build will be started asynchronously. And that might lead to an unpredictable results in the end, right? Because some builds might take longer, and then a new commit makes the code more faster, and it will create a mess. So serial will make sure that there is just one build at a time, and the builds are scheduled properly. There is also a special run policy that we tend to call serial killer, but I think it's a run latest or something like that in the end. So what that is doing that every time there is a new build created and there are previous builds queued, they are just canceled because you don't care about the waiting builds. You just want to have the latest build. These triggers are important. So we have a GitHub webhook URL here. If this will be some publicly resolvable URL, you can just go to your GitHub and to the repo configuration. And what you can do is that you set the hook, and every time there is a push, GitHub will send some payload. It will just do a post or something on that URL. And if that URL is this URL, it will kick a new build. Right. So you can fully automate it from GitHub or from GitLab. I think GitLab also works very well. And yeah, so that's one trigger. Or the other trigger is that if there is a new image available for PHP 5.6, imagine there is a shell shock or something like some vulnerability. If there is a new image available there, it will kick a build, so it will automatically rebuild your application in that case. So you don't have to care if there is a security issue. If your administrator push a new image for PHP as a builder, your application just gets rebuilt automatically. You don't and redeploy automatically. Yeah. And the same for config, so every time I change this configuration, it kicks a new build. Or I can just manually kick it, which I am going to do. So if I start the build here, what you will see is that, oh, well, there is a new build running here. You can actually go see the logs of that build, right? So this is happening on my computer, so it's cloning the source code from this URL as these commits. It's installing application source. This is super simple in case of PHP, right? So in PHP, usually it's just copy, right, and should work. Or in worst case, you have some bloody thing like Composer or something that is installing your dependency. But in other languages like Python, you might actually run pb install or something like that here. So that's the STI script I was talking to you about. So it is called assemble, and it knows how to build the application itself. So in case you're using a Python image, it has assemble set a way that the assemble will do pb install and will do some other crazy things to detect Django and other craziness of Python. And in the end, it will build the application. If you have a Go application, it will do a Go build or something like that. So once the build is done, it is pushing the image to the registry I have running on this laptop. And if that is done, push successful, it will redeploy automatically because there is a new image observed. Okay. Yeah, maybe it doesn't redeploy. No, it redeployed because it's number 2 now. But we haven't seen it. So the console is real time, but that resolution sucks. Sorry. So you will actually be able to see if when the build finish, you can see that the new deployment is going on. I can actually deploy manually. Just. So this is basically what's happening on deploy. So it's scaling down, scaling up, scaling down, scaling up. And yeah, you can ignore that messages because I'm running a developer version of OpenShift itself. This is like a master or something because I'm brave doing live demos on developer versions. So yeah, okay, you can safely ignore this. And you have deployment number 3. I must manually trigger that because there was literally no change. The image doesn't change, nothing. So this is a manual deploy when I really want to redeploy, but there is no change in application. So that's deployments. Yeah, as I said, OpenShift is just running Kubernetes. So, and for that, you have access to pods, like when you have Kubernetes. So you can just create new pods. You can just see details about pods. You can see the environment variable. You can see the logs from the pods, like a std out in the web console. You can even use a terminal, as you see before. So I can just go inside the container and see what's there. Nothing. And you can also see the events from Kubernetes as well here. So what happens, how this container was created. You can also see the services and other things. So I was talking about pipelines. I don't have any here because that require more work. But you can add a pipeline to your project. That means that pipeline is a special build configuration when you create a build, and as an input you give it a Jenkins file. I don't know how familiar you are with Jenkins files or if you heard about that. So the Jenkins files is basically something like similar to Docker file concept when you describe how your Jenkins should be configured. Kind of, yeah. It's more like a definition of all your jobs inside Jenkins and how they relate each other and how they are configured and so on. So you can create a build with this Jenkins file. When you do, OpenShift can automatically provision Jenkins. So it will add the Jenkins to your project. It will give it that Jenkins file. It will configure the Jenkins automatically for you, creating that pipeline, and then in like 5 seconds, you have the full pipeline running. If you know how to write Jenkins files, which means that you know how to write these Groovy or something like that crazy Java language. So if you know how to describe that inside Jenkins file, you might create the pipelines very easily. Yeah, and as I said, there are image stream images. So here I have this tag latest. So you can see the details about that Docker image that I just built. It's based on CentOS. All these informations we are getting from the Docker registry just for reading the metadata and scrubbing a lot of binary crap. So you can see this. You can also see the information about layers, so how that image is layered. So you can see like what is the size of different layers here. And yeah, config, what are the basic environment variables set for this image? and so on. The next thing you can configure is quotas, so you can specify the quota for different deployments and different pods, and basically everything that runs pods can take quota. So you can limit how many CPU, how many memory, how many whatever it can use. You can also limit in a range, so how many pods you can have inside this project, how many replication controllers, how many deployments you can create in replication in this project. Users can do their own, but all admins, like so when the cluster admin comes and install OpenShift, it can set a template for a project. So every project that is created by a user gets this template. So you can easily just account users like these users in this group with this role can only create 5 deployments in their project. So that way you keep the users sane, right? Or admins sane. So users will not go wild as a developers and create like thousands of pods or something like that. You can just say, this is how many pods you can have in your project. I wasn't mentioning storage because that's another 1-hour presentation. But Kubernetes and OpenShift support some storage plugins like Ceph, for example, is supported. The GlusterFS is supported, NFS is supported, Flocker and other like 10 different storage plugins. This is abstracted in Kubernetes. They call it persistent volume. So you can create a persistent volume that is baked by the NFS storage plugin. And basically you create a persistent volume that has 10 gigabytes, right? And you just created it in the system. And then users inside their projects might claim a space. So let's say I want to request a storage, right? And I will call it like my DB. And I won't be able to do it because I don't have an NFS running here, but just showing you. Then I can request like what kind of storage I want, because I might have just a single user, which is like read, write once, or I can have a shared access, read, write many, you know, or read-only storage, basically. And I can request I can request the capacity I want, like let's say I want 200 megabytes, right? And then go create. And that's fine. It's created. I don't have any NFS now. So this will be like, this is just a pending, and I think it will be pending forever now, until I go and create a persistent volume that has enough capacity to satisfy this request. So this is how users can request the volumes safely. You as an admin just create like a persistent volumes and users just claim the space on it. Yeah?
Sorry, so this graphical user interface, is it for the OpenShift administrator, or is it for developers?
This is just for developers.
This is for
Yeah, developers have access to all of these. Yeah, the admins. So if as an administrator, you don't want to have these. As an administrator, you want to have something like a ManageIQ or CloudForms or something that gives you a global view about how many nodes you are, how many pods you have there, how much capacity you have, how much storage you have, and so on. So, and that's a completely different product from this. So OpenShift itself doesn't have an admin console, but it has admin tools in like a CLI tools that you can use for creating volumes, evacuating nodes. It's called OC adm, like for admin. So and that command can be used just by cluster admins. OpenShift client. It's very inventive. Yeah. We thought like kubectl, it's very long, so let's call it OC, just 2 letters. Less typing hurts. So yeah, so you can request storage, and once you have a storage, then you can just go to your application here and say like, yeah, I want to attach volume. Yeah, I want to attach this 200 megabyte volume, and I want to mount it inside data, right? And let's attach it, right? So once this will be possible, because I will have the volume, right? It will redeploy, or maybe it will redeploy now. Yeah. So this deployment will fail because the volume doesn't exist. So it will just sit in limbo now till it realizes that it doesn't have a volume, and will just roll back to a previous configuration. But the application is still running, right? Nothing breaks. Actually, there are some gotchas here. If you have a persistent volumes and you're doing rolling deployments, it's very important to not have the read write once volumes. right? Because the problem with them is that at some point of time, you have two pods running in parallel, both trying to access the same volume. That is just read-write once. So it can be used just by one pod, not by many pods. And that deployment will just fail, because you can have that. Or you can have a read-write many, but you might have then problem like these funky problems with locking and stuff. So you need to deal with that yourself. So that's storage. And the last thing that user can see is some kind of monitoring, what is happening inside my project. So you can see this is, I can see details here inside events, like failed scheduling because of persistent volume climb is not bound, right? Like I don't have any persistent volume that might satisfy these, so which is unexpected, unfortunate, but that will fail that pod, right? You can also see the overview here for the build, like last complete in 16 seconds. Deployments, this is still running. I have these active deployments. And these are the pods that are trying to run. And they will try forever. For deployments, I think the last thing I forgot to mention is that you can also roll back a deployment. So every time something breaks, you can just hit the button and roll it back to a previous version. Geez, I don't think I have it here. Well, there was a button. I don't know what they did it. You can use a CLI tool, which is another thing I was going to show just very, very, very quickly. So yeah, it's called OC, and basically this is you won't be able to see it. Again. So OC status. OC is equivalent to kubectl. So everything you can do with kubectl, you can do with OC. Like OC get pods, right? And you will get the pods. And what is more funny is that when we build OpenShift and we build the OC binary, we also create a symlink called kubectl that points to OC. If you call that binary, it will just call the pure kubectl, because we have a Kubernetes inside. Remember that OpenShift is Kubernetes, so we have kubectl, we just rename it, right? So if I get pods, I get kubectl behavior here. I swear I don't have a Kubernetes on this node installed. So yeah, so you can also manage deployments, like different, like rollouts. Oops. So you can see the history of deployment. You can pause deployment. You can resume. You can undo a previous. All these kind of things. Yeah.
At least from what we've seen from the web application, the UI, there's like a lot of settings and things on it. Can I track it in Git?
Yeah. So every resource in Kubernetes is represented by a YAML file or JSON. And since we thought in Kubernetes and in OpenShift that having users writing a JSON file should be considered as a crime against humanity, so we are trying to hide it everywhere. That's why we have all these CLI tools and everything. What they really do is just managing JSON files and mutating JSON files. I think that's and doing API calls to change JSON files. So yeah, and inside OpenShift, it's funny if you want to know how this thing works, is that in OpenShift and Kubernetes, every resource is represented by YAML or JSON. You can choose because they are equivalent. It's just a different filter. But inside etcd, I don't know if you are familiar with etcd, but that's how the resources are stored together in OpenShift and Kubernetes. And inside etcd, we store it as a protobuf. To make it even more, like protobuf is like a different kind of format invented by Google just because the JSON and YAML are big, and protobuf is like a binary data format that is more optimal for Go applications. It's more fast. So very quickly, for the administrative commands, so you have, as I mentioned, you have an OC adm. So you can install a router, which will create a HA proxy that you can then go access your applications, which I didn't show. So you see this URL. If I click it, I can actually see that application running on my laptop. Come on. So how that works, this is it. It's just boring Cake application. So how this is working, I have a HA proxy. Every time I send a request, the HA proxy will send it to that endpoint of that service. That's OpenShift concept. Doesn't exist in Kubernetes yet. Well, they have ingress, which is very similar, but doesn't offer this out of box. As an admin, you can install this router, HA proxy, with your custom configuration if you want to do some crazy things in routing. You might have a IP failover. You can install registry, Docker registry itself, just by running OC Adam registry create or something like that. It will just create the Docker registry for you inside the project. You can create projects, you can manage policies, you can manage groups, you can manage certificates inside OpenShift. You can manage the nodes. I mean, like you can evacuate the nodes, you can list all the pods that are running on that given node and so on. So as an administrator, you have a lot of things a lot of tools to manage the project itself. You can even run a diagnostic, which will try to give you like what's wrong with it. So the usual question is like, yeah, users will complain that doesn't work, right, broken. So what we invented is diagnostics. So you just run OC diagnostics, and it will give you the report that you can then send us, and it will tell you what's wrong. So, yeah, you can also prune. Pruning is very important here. So if you're running a massive, like a very big scale cluster, you might want to prune some of your data, right, because they will just grow in etcd, like images. It costs money. Okay. And yeah, and I think that's it. I think I'm very over time. So if you have any questions, like you can catch me after, or we can, yeah, we can talk about later. So thank you. Or do we have a time for questions?